It's been a fun series of presentations to give. I know some people have been sending in questions already. I want to address some of them right now. In one of the presentations, I showed some signal processing techniques. One delegate asks, can you use windows on your signals, such as panning and other windows? Otherwise, you introduce errors. Well, yes, you can. There was a principles worksheet that I wanted to go through in greater detail, but I didn't have time during the event. Let me just see if I can find it. So here we go. This just gives you more information on the signal processing tools in Maple. So yes, there are a large number of windows. The signal processing package is actually something that I've personally been working on over the last few releases. So we've been slowly introducing more and more functionality into the tool. There's some really interesting things you can do with it. The same delegate asks, can you plot filters, amplitude, and phase? The answer is yes, you can plot the frequency response of the filter. And I think I already had a worksheet of this one here. All right. So a number of steps to this. First of all, I generate the taps for a finite impulse response filter with a Hamming window supplied. It's a low pass filter. And then I use this function from the signal processing package, filter frequency response, to plot the response and the phase. Of course, one of the fun things about MapleFlow is that you can play about with parameters, commands, and see the effect they have straight away. So I could change this cutoff frequency. You can see the change there. I could change this to high pass filter. And all of the plots update accordingly. Another question, can you import PDF images as they're vectorized and long-lived? This is something that a number of people have asked. It's on our development roadmap. It's something that we're seriously considering. It's not something that we plan to do in the next year, but perhaps beyond that. So one question is based upon the civil engineering presentation. Is your bolt calculation assuming friction bolted connections? I have to admit some ignorance on this. I simply grabbed an engineering textbook which described the instantaneous center of rotation method, and I implemented the equations. I'm not sure what, and then I cross-checked the results against the tabulated data in the AISC steel construction manual. I didn't actually check the, I can't remember what the assumptions in the engineering textbook were. So on that, I must admit some ignorance. Another question, can I read in a vector with 2 million elements? Well, we're currently optimizing the MapleFlow computational engine. For applications, we're actually reading in millions of data points from external files, then manipulating them. At the moment, I would recommend Maple. That's our tool for mathematically intensive tasks. In Maple, you can easily read in data files with 2 million elements. It's probably best if a file with that many data points it's probably best if that's in a binary format. It'll be far, far quicker to read in. Binary data files just dump the data from the local file straight into memory. So one person asks, are there any material properties built into MapleFlow? So there are a number of sources of materials property, although it depends on what your definition of a material is. We actually have a thermophysical data package which lets you extract the thermodynamic and thermophysical properties of pure fluids, fluid mixtures, humid air, and there's also atmosphere models in there as well. So this is how you'd use the package. So let's start off by extracting the density of water at a temperature of 400 Kelvin and a pressure of 1 bar. So the value of rho is, there we go. There's lots of other things you can do with the thermophysical data package. I think I mentioned standard atmospheric models. With the data in the thermophysical data package, you can model thermochemistry problems, combustion problems. You can model the energy flows across a refrigeration cycle and calculate the coefficient of performance as well. One person asks, can you implement headers and footers in a MapleFlow canvas? The answer is yes, you can. If I go to the View menu, Insert, Header and Footer, this brings up this window, which allows me to specify a predefined header and footer, or I can customize my header and footer with dates, page numbers, specific text, images, file names. In MapleFlow 2022.1, which will release in the middle of this year, you'll also be able to add a frame or a black border around the header, the footer, and the body of the calculation as well. One person asks if you can structure a canvas with sections. The answer is yes, you can. If you go to the Insert menu and select Section, this inserts 2 horizontal black lines across the length of my document. I can simply move these up and down to delineate more or less of my canvas. There's a text box associated with the top line in which I can add a title. And I can expand and collapse this at will. Oh, so one person asks about the underlying grid in MapleFlow. So there is an underlying grid in your canvas. If I toggle this button, that shows the grid on screen. So I can, when I move things around, everything snaps to the grid. So if I just drop this container here, you can see it snaps into position. That's a nice way for you to align things nicely on your worksheets. I usually have the grid switched off, but I know some people like to have the grid switched on when they're working in MapleFlow. My own preference is a clean, uncluttered environment. So one delegate asks about long path names, and that's something we're working on. So long path names in headers and footers, as I said, that's something that we're working on. Somebody asks if MapleFlow has UI elements such as drop-down menus, buttons, checkboxes. That's something that's in our long-term development roadmap. It's not something that we'll have in the next year, but it's something that I personally want in MapleFlow. And it's something that many of our users want as well. All right, one person asks if I can just speak about plots and visualizations in MapleFlow in greater detail. I can certainly do that. So MapleFlow is actually based upon the Maple programming language. You have access to nearly all of the plotting tools and options in in MapleFlow. So the basic command is this, plot, give it a parameter, the expression that you want to plot, and the range over which you want the plot to be created. If you evaluate this, it gives you this plot. You can move this into position, expand this, contract this, and with the command line options, you can fine tune the appearance of this plot. So grid lines, colors, fonts, ranges, and so on. The complete list of options for the plotting command are actually given in our help menu. So if I go to help, MapleFlow help, go into plots, and let's open up this help page as a worksheet. So this is the help page for the plotting command. It describes all of the options here. There's also a number of specialized plots in MapleFlow as well. So we've already seen some tools for phase plots, magnitude plots, Nichols plots. There's also a large number of thermodynamic plots in MapleFlow as well. So this is a pressure, enthalpy, temperature plot for water. This is just a normal maple plot, so you can overlay lines, shapes, and other elements on this to indicate the flow of a thermodynamic cycle. Somebody asks, can you paste an image from the clipboard into a document? At the moment, no. It has to be imported by the insert image menu, but that's something that we have planned in the very near future. You'll be able to do this in Flow 2022.1. That'll be released maybe during the summer. So somebody just asked me to expand on some of the atmosphere models in MapleFlow. So these are just standard atmosphere models. I'll show you the help page. Which return a typical density, pressure, viscosity, and speed of sound at a particular altitude. So here, what I'm just going to do is copy this math container into a new worksheet. So here, this is giving me the expected speed of sound at an altitude of 10 kilometers. Let me just remove some of these parameters since I don't think they're necessary. And there we go. If I change this to 40 kilometers, that's the expected speed of sound. And here's the expected pressure, temperature at that altitude. So one of the cool things you can do with MapleFlow is something like this. So you can assign this to T. Quite often you'll end up with long function calls and you don't necessarily want to see the bit in the middle, the command. If you right click on this and select hide command, you're left with this, just the name that you assigned the result of the command to and the result. The command is still there, it's under the hood, but it's out the way so you don't get overwhelmed by it. So somebody asks if we're open to input on our development from users and potential users. Yes, we certainly are. We want your feedback. I personally couldn't do my job properly without feedback from our users, both current and future users. If there's anything you want to see in the product, either in MapleFlow or Maple, please do let me know. We log everything. We take each request seriously. Of course, we have to prioritize development requests. If 100 people ask us for feature X, but only 2 people ask for feature Y, then of course it's feature X that gets priority. So we do have to prioritize, but we do take everything seriously. Every suggestion is logged and looked at. I have a comment, not a question, from an attendee. I'll just read it verbatim. Seismic signal programming features developed in the 1960s or early 80s don't seem to exist, but are at the core of civil engineering calculations in seismic regions. They can spectrum match linearly or perfectly match the initial earthquake record to project target spectra. The delegate also says, I might have to send Samir some 60-year-old papers. Please do. Right, somebody asks, can you use the thermodynamic data in a function? Yes, you can. If I understand your question correctly, what I can do is make any call to thermophysical data a function of a parameter. So for example, I could say that the rho is a function of T, where T is the temperature. So now I can evaluate the density at any temperature. 300 Kelvin. And 350 Kelvin. It's a little bit different there. All right, one person asks about resources and examples. In the product itself, we have an application gallery. If you click on this link in MapleFlow, this is just an application gallery across a number of disciplines where we have users. So aerospace engineering, chemical engineering, electrical engineering, civil and structural, and pipeline design. There are many more MapleFlow examples on the MapleFlow Application Center. If you go to our website, maplesoft.com, and you go to the Application Center and then filter for MapleFlow examples, I think there's currently about 130 MapleFlow documents that you can just download and use straight away. I'll wait 1 or 2 minutes for more questions. All right, somebody asks, how can we be guaranteed that we can still open MapleFlow sheets in 30 years? It does not work in Word. But I use Adobe FrameMaker and open 1995 files today. Can you guarantee the same? I can't explicitly guarantee that you'll be able to open MapleFlow worksheets that you create today in 30 years. We do see a very long timeline for MapleFlow. It's a tool that we imagine will be in use in 10 years, in 20 years, in 25 years. But file formats do change. I can't predict what will happen in 10 years' time or 15 years' time. But PDF seems to be a fairly universal standard. As I mentioned earlier, there is an ISO standard for long-term storage and archival of PDF documents. And given the ubiquity of PDF documents, given the number of people who know and use PDFs, can well imagine that PDFs will be, you'll be able to read PDFs that you create today in 20 years' time. For example, picture files like BNP files or GIF files. I can open up picture files that were created 15 years ago in software that I can download and install today. I imagine I can do the same with the PDF file. Okay, somebody asks, can you set up atmospheric pressure and temperature versus height? I think there's a demonstration of that on the help page here. So if I scroll down, here you can see that I've plotted temperature, pressure, and I think the other parameters predicted by the atmosphere's model against the height, the altitude. So yes, you can. So one person has a comment. About the remarks I made about PDFs. They warned me that Flash died. Yes, Flash certainly did die. It died a deserving death a long time ago. So yes, I'm aware that certain electronic formats do die out. All right, there are no more questions coming through. So hopefully everyone's been able to ask their burning questions and make comments. If you do have any questions or comments in the coming hours, days, weeks, or months, then please do let us know. Send us an email. And we'll be more than happy to respond. But for now, I'd like to draw a line under today's event and thank everyone for listening to the various presentations. Thank you.